Hey, I got my eye on you. Get it? You will, don't worry. Anyway, let's talk about ions, okay? So, what is an ion? Okay, ion is simply an atom with a charge. Okay, and charges can be either positive or negative. So it's pretty simple. Now, here's the deal with ions. Okay, first of all, if you think, since you know, you says yourself, protons are positive and electrons are negative, right? Which means, so let's take a look at what this would actually look like. All right, go purple for this one. So here we go. Here is an example of, let me change it. Hold on, let's do what we did last time. Go black. Okay, this is going to be a positive ion. Oh yes, and by the way, when I said, you know that protons have a positive charge and electrons have a negative charge, you might think, well, if you add protons, you can get more positive charge, and if you add electrons, you can get more negative charge. The second part of that's true, but not the first part. You don't mess around with the protons. Okay, that's the nucleus of the atom. All of this business here with ions takes place with the electrons. Okay, and this will be a negative ion. So I'll show you what I mean. So first of all, let's go back to our 1, 2, 1. We'll do our helium example again. And let's put a couple neutrons. This time we'll make them both the same. Okay, we got 2 helium atoms. And we're going to go, we have our, okay, in this case, okay, so notice in this case, and again I'm going to write the fact that these are both helium. Now this isn't, helium does not like to form ions, but just for, since it's a nice simple atom, we'll just use this as an example. Notice, in this case, I have 2 positive charge and only 1 electron up there, 1 negative charge. So that leaves, if I add 1 plus, or 2 plus, and 1 minus, that equals 1 plus charge. So this helium atom has a net positive charge because there are 2 protons and only 1 electron. And remember, the neutrons don't have a charge, so they don't figure into this. On the one on the right here, notice that I have 2 protons, but I have 3 electrons. So that's 2 positive and 3 negative. If I add those up, it gives me a 1 negative charge. There's an additional negative charge that's not canceled out by the protons. So this would be an example of a positive and a negative ion. Notice, you don't change the number of protons. Okay? Don't mess with the protons. Okay, so you only mess with the electrons. Okay, so atoms who have fewer electrons than protons will have a positive charge. Atoms that have more electrons than protons will have a negative charge. And that is what ions are. Okay, it is all about electrons, okay? And the reason that is, and just so that we're aware, okay, once again, I'll do purple. Here in the nucleus, protons and neutrons are way on the inside. Remember we said that protons and neutrons are way on the inside of the nucleus. The electrons orbit all the way out here. And if these are the electrons, it's easier to mess with them because this is what is on the outside world. So remember, the electrons are like your bubble. And way, way, way down in the middle, you have the nucleus. Okay? It's very hard to get to the nucleus. So to get to the nucleus, remember, what keeps the nucleus together is the strong nuclear force. Okay? And the SNF, okay? And what keeps the electrons orbiting around is electrons. electrostatic. Electrostatic force is much, much weaker. It's weak. And it's easy to mess with, okay? So messing around with electrons, adding them and taking them away is way easier, okay, than messing with the nucleus, which is a strong nuclear force. Very hard to add or subtract protons or neutrons. Once they're in the nucleus, they're bound by that SNF, and it's very hard to mess with them. So that is why it's about adding or removing electrons and not adding or removing protons.